Alright guys, working on section 1.4 of the student journal, solving absolute value equations. How can you solve an absolute value equation? So this does, starting on page 17, we're just going to skip that stuff. Now we're going to go straight to the definition of an extraneous solution. So before we do anything, this is important to cover because extraneous solution is a solution that actually, you know what? Let's go by the dictionary definition. Define extraneous solution. In mathematics, that emerges from the process but is not a valid solution. Okay, so it's an answer that does not work. Solution that does not work slash does, yeah, solution that does not work. So why is it a solution? Don't ask me that. You get it. You plug it back in, and it doesn't work. So after solving, substitute variable to check. So I substitute for variable to check, and you'll see what I mean in the course of this lesson. So that's that. Properties of absolute value. So this assumes that you remember, but if not, we can go over it real quick. Absolute value of a is equal to or greater than 0. So absolute value just refers to distance from a, and when you're referring to distance, it's impossible to be negative. Like even if you're, let's say you're racing and you're behind someone by a mile. They say you are behind by a mile, but the distance between you two is still a mile. It's not -1 mile, right? The distance is still the same, whether you're ahead or behind. The absolute value of a is equal to or greater than 0. That means it has to be what kind of number? A positive or 0, but it cannot be negative. The absolute value of negative a is the same thing as the absolute value of positive a. If you multiply two numbers and take the absolute value, that will be positive. It will be the same thing as if you take the absolute values of each separately, because they will both be positive anyways after you do this, and then multiply them. Lastly, the same principle applies to division as it does to multiplication. Obviously, the extra condition is that the b cannot be equal to 0 because you cannot divide by 0. That's page 19. To solve, then, you realize that if the answer will always come out positive, then it doesn't matter whether you set the inside to a positive or negative. So this is saying to solve the absolute value of ax plus b is equal to c when c is greater than or equal to 0, because what number can an absolute value never be? Negative. It can never be negative. Then we are going to make two linear equations, ax plus b equals positive c, or ax plus b equals negative c. What do I mean? Easiest way is to show you. So for something that's extended like this, then you make sure that whatever it is, cx plus d is in parentheses. You'll have to make the whole thing negative, not just the cx part. So again, positive, negative, positive version, negative version, but the whole thing has to be negative. The whole expression, rather. So I have 3x plus 12 equals 0. This one you should, if I say 3x plus 12 equals -0, that will be the same thing because 0 and -0 are the same. So the related absolute value equation for this one is simply 3x plus 12 is equal to 0. And we could subtract 12, and we can divide by 3. Subtract 12 from both sides. At this point, you should have it down, but I will do it anyways, the left side and the right side of the equation. 3x equals -12, and then divide both sides by 3. So you have x equals -4. Now notice, it's not that my solution cannot be negative, it's that an absolute value cannot be equal to a negative, right? So this is still completely valid. X equals -4. Graph the solution. Where is that? Bada bing, bada boom. Right there. Pretend I'm right in the middle of that 4. If you plug it in, it still makes sense. 3 times -4 is negative 12. Negative 12 plus 12 is 0. The absolute value of 0 is indeed 0. Okay, moving on. So this is a perfect example for when we would use two linear equations to work this out. So we have y plus 2 equals, in this problem, c is 8. So you have to make it positive and negative. Subtract 2, oops, I forgot to divide it into sides, left side and right side, left side and right side. In both cases, we are just going to subtract by 2. Boom, boom. Sorry if I'm doing a lot. Y equals 6. I'm writing it up here so I have space later. Y equals negative 8 minus 2 is negative 10. So again, I have negative 10. Circle that. Well, whatever. Circle that. Y equals 6. Circle that. Fill in the circle, I mean. If you plug it in, 6 plus 2 is 8. Take the absolute value of 8 is 8. You have negative 10 plus 2. Negative 10 plus 2 is negative 8. But again, the absolute value sign gets rid of the negative, so it becomes positive 8. So we're still in good shape. For this one, you'll see that there is a number, negative 4, outside of the absolute value. When we do this, the best thing to do, or I don't know, just what you got to do, is to make sure that the absolute value sign is by itself. So how do you get rid of this? Well, ask yourself, what is happening to this negative 4 and the absolute value sign? Do you see any symbols? You see a negative, but that doesn't mean minus. There's nothing in between the negative 4 and everything else. So that means it is multiplication. How do you cancel out? What is the inverse operation of multiplication? Divide. Nice little fraction bar. Divide by what? You're going to use the same number that we are trying to get rid of. So negative 4. Here as well, I'll write it in this time. Negative 4. So we have absolute value of absolute value of 7 minus 6k. 7 minus 6k. Pretend that's a 6, not a g. Golly. Is equal to, pretend that's a 6, not a g. 14 over negative 4 is 7, negative 7 over 2. And here's a reminder. This is where things get actually really simple. Can an absolute value ever be negative? Right? There's nothing else to work out. There's just this, whatever is in there is going to come out to be a negative. Is that ever possible? No. No solution. And if there's no solution, we have nothing in the graph either. So, fantastic. Alright, moving on. Number 4. We got 4. So again, we got d over 3. And this is a positive, so it does work out. Or it's greater than 3, or greater than 0 rather. Equal to or greater than 0. So, we got d over 3 equals positive 3. And he's in my lap. And d over 3 equals negative 3. Hello, Bond. My dog is just taking a little nap. Alright, so we got d over 3, multiply by 3. Multiply by 3. Boom, d equals 9. And you'll see, you do the same thing on the other side. You just multiply both sides by 3. You get d equals negative 9. So I got that and that. If you plug it in, it checks out. 9 divided by 3 is 3. So the absolute value of 3 is 3. Negative 9 divided by 3 is negative 3. Absolute value of negative 3 is 3. Okay, so for number 5, we have even more interference with our absolute value. And so to do that, to deal with it, we have to get rid of all that other extra stuff first. So let's start with the 10. We're going to start with the 10 because when we use inverse operations and there's multiplication to deal with the 3, and there's addition or subtraction to deal with, you're going in reverse order of operations, so you go ahead and take out the addition and subtraction first. So I got 3 parentheses, or sorry, absolute value, 2x plus 5 equals 27. Now I can divide both sides by 3. Writing with the mouse is just, it is just awful. We got 2x plus 5 equals 9. Now I'm going to write out the 2 linear equations for you, and I will leave them for you to solve. Because if you're following earlier, like I understand if all this over here was difficult, but here I've broken it down to be just like 1, 2, 3, 4, and 4. So I have 2. Sorry. We got 2x plus 5 equals 9. That's equation 1. 2x plus 5 equals negative 9. You'll subtract 5, and then you'll divide by 2, and whatever it is you get, that should be it. All right? So that's it for 1 through 5. Moving on. Again, I'll write these out, but I'm just, let's see, 20x equals 4x plus 16, just for example. 20x equals negative 4x plus 16. Remember, we got to put it in parentheses when we have more than one term. You got to make the whole thing negative. And you know what, while I'm at it, I'm just going to write out the others as well, just because it's annoying clicking back and forth on that transparency button. P plus 4 equals P minus 2, and P plus 4 equals negative. Notice again that I'm doing the negative, or everything else is written in parentheses. 4q plus 9 equals 2q minus 1. 4q plus 9 equals, what do I got to put around them? Before I make, or right after I make the negative, parentheses. 2x minus 7. So just as a heads up, for these problems, we are really going to see these like, you're going to see the extraneous solutions. We'll check our work and see what comes up. Negative 2x plus 9. Whew. 2x plus 9. Okay, so that's that. Going about solving it, subtract 4x. Subtract 4x. I get 16x. 16 times some number is equal to 16. Oh boy, what number is that? Divide both sides by 16. You get x equals 1. Here we're going to have 20x, and before we can do anything, we've got to distribute this negative. So I have negative 4x minus 16. We're going to add 4x, so we get 24x equals negative 16. This is for simplified form, negative 2 over 3. If you divide the numerator by 8, negative 16 divided by 8 is negative 2. Then you also got to divide the denominator by the same thing. 24 divided by 8 is 3. So we got x equals negative 3, and we have x equals 1. But it says to check our solutions. So remember, our answers are negative 3, or sorry, negative 2/3, and positive 1. So just doing that like this. Oops, let me erase that as well. So just thinking about it, 20 times 1 is 20. Let's check that one first. It's going to be simple. 4 times 1 is 4. 4 plus 16 is 20. Okay, that should have been obvious. Negative 2/3, I guess it's going to be a little dicier because, well, we have a negative and a fraction. So 20 times negative 2/3 is negative 40 over 3. And if I take the absolute value of it, the negative sign goes away. I have 40 over 3 on the left side. Negative 2/3 times 4 is negative 8/3. 16 is 16 over 1, but to turn it into a fraction, I could say, I could multiply the numerator and denominator by 3 and say 48. Negative 8 plus 48 is going to be positive 40. We take the absolute value of it. And both of our answers are legit. Sweet. I was almost erased all that precious work. But those are our two answers. They're good. The next one, p plus 4 is equal to p minus 2. Let's see. Subtract p, just because we can. You can bring it to the left or right side, but in this case there's none. 4 equals negative 2. Does that work out? Is that any solution? Is 4 equal to negative 2? The answer is no. Alright, so let's just move on to the next one. Distribute this, distribute that. So p plus 4 is equal to negative p, and a negative times a negative 2 becomes a positive 2. Now I can add p to bring it to the left side. I got 2p plus 4 is equal to 2. Now I can subtract by 4. So I'm just working on isolating the variable. Negative 2 divided by 2 divided by 2, p equals negative 1. And it says to check our answers. Here we got none, so we don't even have to worry about that. Negative 1. Negative 1 plus 4 is positive 3. Negative 1 minus 2 is negative 3. But when we take the absolute values of both of those, we get 3. So bada bing, bada boom, it works out. We can erase this now. I don't know why I'm bothering. Just make the screen like neater and less visually distracting. This one, subtract 2q, subtract 9 divided by 2. So I'm not going to bother showing my work because it's a time issue for these videos. But you should get minus 9, q equals negative 5. So we check it. Negative 20 plus 9 is negative 11, so positive 11 is the absolute value of that. And then negative 5 times 2 is negative 10. Negative 10 minus 1 is negative 11, but the absolute value of that is, again, positive 11. So we're good. This one, you will get negative 2q plus 1, 4q plus 9. So I'll subtract 9. Or I will add 2q, so I get 6q, and then I'll subtract 9, so I get 6q equals negative 8. Divide both sides by 6. Q equals negative 4 over 3. Okay. And last but not least, 2x minus 7, 2x plus 9. If I subtract 2x from both sides, what will that look like? Let's just type it out. Minus 2x, left side, right side, cancel, cancel. I get negative 7. Don't forget that. Negative. Don't do that. Don't ever do that. Negative 7 is not equal to 9. This makes no sense. No solution. Over here, we have 2x minus 7 equals negative 2x minus 9. So I'm going to add 2x to both sides. I will add 7 to both sides. And then I will divide both sides by 4. X equals negative 0.5. Alrighty, that's it. Again, if you have any questions, let me know. Otherwise, hope you understood the lesson.